How to convert rectangular form into polar form? Already you know what is a rectangular form and you know what is polar form. Now it is our duty now to convert a rectangular form into polar form as well as a polar form into a rectangular form. For that, let us consider complex number z is equal to x plus iy. Here all the representations are given. This is your real value, this is your imaginary value, this is the modulus value, this is the argument value. Everything is given. Now let us try to find x value. You just consider now that you know the value of r and theta. So let us try to find the value of x. For this theta, this is your opposite side and this is your adjacent side. So we have to find adjacent side and hypotenuse is given. So try to find a formula which is linking adjacent side with hypotenuse. So that is cos theta. Cos theta is equal to adjacent side by hypotenuse. So that is your adjacent side is x and your hypotenuse is r. Make this r to go this side, your x value will be equal to r cos theta. Similarly, let us try to find the value of y. How to find it? This y is our opposite side. Already we know the hypotenuse value. Apply the formula which is linking opposite side with the hypotenuse. That is sin theta. Sin theta is equal to opposite by hypotenuse. That is equal to y by r. If r goes that side, your y value will be equal to r into sin theta. You know z is equal to x plus iy. So let us do one thing. Instead of x, we can substitute r cos theta. For y, we can substitute r sin theta. So that is r cos theta, r sin theta. That is x plus iy is equal to r cos theta plus I into r sin theta. If you take r commonly outside, that is x plus iy is equal to r into cos theta plus I sin theta. This is simply written in this way: r into cis theta. C stands for cos and I stands for imaginary and S stands for sin. This theta is your argument. So if you want to convert a complex number which is in the rectangular form, that is x plus iy, then the formula is r into cos theta plus I sin theta. How to find the r value? If you know x value and y value, we can find r value using the formula root of x square plus y square, and we can find the theta value by using the formula tan inverse of y by x. Now let us try to convert a complex number which is in the rectangular form into polar form. For that thing, you have to remember some important facts. That is that if z is equal to x plus iy, you know its modulus value is r is equal to root of x square plus y square, and its argument is theta is equal to tan inverse of y by x. Right. Now we have to follow some rules to convert a complex number into polar form. Right. How to convert it? Right. Here are the rules. First, try to mark where this complex number lies, whether in the first quadrant or in the second quadrant or in the third quadrant or in the fourth quadrant, by seeing the sign of real part as well as the imaginary part. In case the sign of real part is positive as well as the real imaginary part is also positive, then it lies in the first quadrant, because if real is positive and imaginary is positive, then surely that complex number will be lying in this first quadrant. In case if the real value is negative and imaginary value is positive, real value is negative and imaginary value is positive, then surely it will be lying in this quadrant. So first you have to mark in which quadrant it lies. After that, apply the formula which is given here. If it lies here, you have to apply theta. If it lies in the fourth quadrant, apply minus theta. If it lies in the second quadrant, pi minus theta. If it lies in the third quadrant, you have to apply minus of pi minus theta. This is the rule that you have to follow. Otherwise, you cannot get angle, that is argument, in the exact methodology. So First, find where z lies. Second, keep y by s positive in mind and find the table angle. Because while doing this problem, that is while trying to find the value of theta, your tan inverse of y by x will be sometimes you'll get the answer as positive, sometimes you'll get the answer as negative. Best way is try to keep this value in your mind as a positive value, and for that positive value try to match the trigonometric table value, right? Apply the formula as in the graph and follow this trigonometric table. If you follow this trigonometric table, you can do it very easily, right? These are all the procedures to convert a complex number which is in the rectangular form to a polar form. Now let us try to do a problem, then you can easily understand things. Convert -1 plus I into polar form. How to convert it? As I told you already, first of all you have to find where this complex number occurs. That you must note. Before doing the problem, let's remember the points. That is, if z is equal to x plus iy, then its modulus value is r is equal to root of x square plus y square, and its argument is theta is equal to tan inverse of y by x. We have to apply all this formula. Also, we have to follow this table, and final conversion for a rectangular form of x plus iy into polar form is r into cos theta plus I sin theta. Right. Now let's try to plot the point. Z is equal to -1 plus I. See where it occurs first. Here -1 is your real part, so your real part is negative and your imaginary part is positive. So your real part is negative and your imaginary part is positive. So here it lies. So it lies in this particular quadrant, that is in the second quadrant it lies. Sorry, it is imaginary positive negative, but it is written as real part negative. Just you make this change here, right? Now first let us try to find r value. That is, r value is nothing but real part square plus imaginary part square, and inside the square root. So your answer will be equal to root. Now you know the modulus value, r value, you know it. Similarly, let us try to find theta, that is argument value. That is, theta is equal to tan inverse of y by x, that is imaginary part by real part. Your imaginary part is 1, your real part is -1. So tan inverse of imaginary part by real part, by simplifying it, we'll get the answer as tan inverse of -1. Already I told you, whatever it may be, you just think even your answer is tan inverse of -1, but anyhow in your mind try to keep this -1 as +1. So try to follow this methodology. Try to find tan inverse of 1. How to find tan inverse of 1? Just go to the table, find the value of 1 in the tan segment, and find the angle, that is 45 degree. You know that 45 degree is nothing but pi by 4. So now you have found what is the argument, but this is not the exact argument. You must be very careful, right? Then how to find the exact angle or the argument? Go and see in which quadrant it lies. It lies in the second quadrant. What is the formula for that? That is pi minus theta. So you have to apply this formula. If you apply this formula, that is, if you replace this theta by pi by 4, you will get the real angle or the real argument. So that is pi minus pi by 4. Pi minus pi by 4. If you simplify it, your answer will be equal to 3 pi by 4. So now you know what is argument, what is modulus, as well as what is argument, that is r value as well as theta value. So if you know r value and theta value, it is very simple to convert x plus iy into the form of r and theta. So you know the formula, that is x plus iy is equal to r into cos theta plus I sin theta. Here x plus iy is nothing but this complex number minus 1 plus I, r value is root 2, and theta is 3 pi by 4. So this is the answer for this problem. So now we have converted a complex number which is given in the form of rectangular into its polar form. I hope so you would have understood how to convert a complex number which is in the rectangular form into polar form. This is the best methodology to complete any type of problem which is in the rectangular form to be converted into a polar form. I hope so you would have understood it. Keep on doing this type of problems using your textbook. Improve your knowledge, then only we can proceed for the other difficult sums. Thank you.